Hey, what's up? It's your old pal, Mr. Cook, and we are going to be continuing on the 10.1 notes. It looks like we're on the third section, which is the coterminal angles. Okay, so coterminal angles, what are they? Coterminal angles are any angles in standard position that have the exact same terminal side. So a real easy way to kind of like think about that is actually this sentence right over here that I'm going to circle for you, put a box around it, because this is like a really important concept to know. Okay, so make sure that you know this. When you see coterminal angles, think about this part of it instead, where we're going to be adding and subtracting 360 if it's in terms of degrees, or 2 pi if it's in terms of radians, to find additional coterminal angles. Coterminal angles are always 360 degrees apart, always. Okay, that's how you find additional coterminal angles. If we're talking radians, it's always going to be it's always going to be 2 pi radians away from each other. So let me show you an example or two. Let's do the degree ones first, because those are a little bit easier for you guys to probably manage at this point. 130 degrees, so if I took 130, and if I were to find a coterminal angle of that, all I need to do is just add on 360 degrees. That's it. Because what does 360 represent? It's a full circle, right? So if I draw out a 130-degree angle, let's just draw one out really, a little crappy drawing here. Here we go. So 130 degrees would probably be something like this, okay? So there's your 130-degree angle right there. If I were to add on a full circle to it, 360 degrees, and then add on that 130 degrees, it'd still end up in the exact same spot. You see, like, why these are called coterminal angles? And why it's the same exact terminal side? It's because it's the exact same position. It just adds on a full circle. So it puts it back in its original position, no matter what. So that's why we say that we can just keep adding on 360 or subtracting 360, because it still puts it in the exact same position. So let's fix this up. So 130 degrees and 360 degrees, that's going to add up to 490 degrees, which is an angle that we had in the previous example, or one of the previous examples. I can add on another 360 degrees. So if I took that 490-degree angle and added on 360 again, that would give me another coterminal angle. So what would that be? That'd be 850. And, alternatively, I could have started by subtracting them instead. 130 degrees minus 360. That's just going the opposite direction. But again, in a full circle. So it still puts it at the exact same position. And 130 minus 360 would give you a negative 230 degrees. So that's an example of a negative coterminal angle. Okay, let's move on to the next example below that. So we start off at negative 210 degrees. So if I want to find another negative coterminal angle, that's pretty easy. I can just take that negative 210 and subtract 360 away from it. So if I do that on my calculator, negative 210 minus 360 should be a negative 570 degrees. Okay, so that'd be a coterminal angle with negative 210. And if I want to find some positive coterminal angles, I can just take the negative 210, and instead of subtracting, I can add on 360 degrees. So if I did that, what would I end up with? 360 minus 210, that's 150. Yeah, so 150 degrees. So a 150-degree angle and a negative 570-degree angle puts you at the exact same position as a negative 210-degree angle, just with a couple extra circles on it. Okay, it's pretty easy stuff. And if you thought that was easy and you think the radians are going to be difficult, then you're off by a bit, because all you need to do is just, here's a little secret. Convert them to degrees, okay? Just that's all that you need to do. Take the radian value, multiply it by 180 over pi to convert it to degrees. So if I do that, 3 times pi times 180 over 4 times pi, the pi's cancel out. So then I get 3 times 180 over 4. 180 divided by 4 is 45, so that's 3 times 45, which is going to be a 135-degree angle. All right, so check it out. All you need to do to find some coterminal angles with that is take 135 and add on 360. So you get, what would that be, 495? And then again, after that, just convert it back to a radian value. So multiply it by pi over 180. And you start to see, how this stuff can be pretty easy. If you can get the hang of just, converting from radians to degrees and back, it makes it really, really easy to, kind of work through these problems instead of working with a bunch of fractions all over the place. Because I'll show you how to alternatively get to this exact same answer using fractions instead here in a second. So 495 pi over 180, and I know that both of those are divisible by, geez, 5, I guess. Yeah. So the top number, 495 divided by 5 would be, it's just under 500, so 99. Yeah, 99. So 99 pi, and then 180 divided by 5, that'd be see, it's short of 200. It's by 20, so 36. Yeah, 36. And then both of these are divisible by 3, so that'd be 33 pi over 12. And those are both divisible by 3, so that's going to be 11 pi over 4. So 11 pi over 4 is going to be our answer for this one as a coterminal angle. Geez, that seems like a lot of work, right? But that's because we're trying not to work with a bunch of fractions and adding them and subtracting them. But let me show you how you can do that with just regular old adding instead of converting and all that. So if you were to take that 3 pi over 4 and you wanted to find a coterminal angle, all you'd have to do is add on 2 pi to it, okay, to keep everything in terms of radians. So you have that 3 pi over 4 and then the 2 pi. And so now what I'm going to do is add these fractions together, and to do that I need to find a common denominator for 2 pi. So 3 pi over 4 is fine, but then 2 pi, I can turn that into 8 pi over 4, because if I multiply the top and the bottom by 4, top and the bottom by 4, then I get 2 times 4, which is 8, and then 4 times 1, which is 4. So adding those two together, 3 plus 8 is 11, also 11 pi, and then the denominator stays the same, so 11 pi over 4. So see, we get the same answer. This is a little bit faster, obviously, because I know how to work with fractions, but if you were just scared to death to add fractions and subtract them, then using the other method of converting to radians, from radians to degrees and back, is your only shot. Okay, so I'm going to go ahead and just add the fractions for this one, because this one's going to be a lot easier for me, just because I can add fractions, and I think that I'd like you to try to add the fractions together. There's ways to do it on your calculator. Maybe I'll show that also on maybe a video or two. But anyways, I want to find a coterminal angle with this. So what I'm going to do is take that 7 pi over 5, and I'm going to add on 2 pi. So I need to find the common denominator. So 2 pi over 1, and then multiply the top by 5 and the bottom by 5. So I get negative 7 pi over 5 plus 2 times 5 is 10, so 10 pi. And then 5 times 1 is 5, so 5. They have the same denominator, so I get it straight across. 10 minus 7 is 3, so 3 pi over 5 would be my coterminal angle. And obviously you can find another negative coterminal angle by subtracting 2 pi instead. But there you go. That's all that you need to do for that. And yeah, I'll try and put up a couple of additional examples for this as well in a video, but those are all the examples that we have for this particular section. So we're going to make a separate video for the other definition that we have in this new one, and that's going to be the reference angles. And those are pretty easy as well. They just take a little bit of time to work through and get the hang of. So that'll be the end of this video. If you need a little bit of additional help, don't be afraid to reach out to your math teacher, find them during their office hours, and ask them why. Okay, that's it for this one. On to the next video.